Hello guys, and welcome to Chapter 1, Day 2. Today we're going to be talking about the distance and midpoint theorems. Now, as a refresher from the last PowerPoint, we're going to go over these words. Now, the word congruent means same size, same shape. In this instance, we are talking about shapes. Alright, shapes, not numbers. Okay, we're not talking about numbers here, just shapes. So when you have two congruent segments, this is equal. This is talking about numbers. Okay? Equal means numbers. Congruent means shape. And that's a good way to keep them separated in your head. So if segment DE, and I'll put the segment symbols on top. If segment DE is equal to segment FG, well then that means that segment DE is congruent to segment FG. Okay? If something is congruent, then it's also equal. If something is equal, then it's congruent. Now, the midpoint of a segment, is the point that divides the segment into two congruent pieces. Okay, we're talking about a midpoint. So therefore, it's a point. Okay? What that means is if you have a line segment, has to be a line segment. You can't cut a line in half because it goes on forever. And if P is in the middle right here, then AP is equal to PB and or AP is congruent to PB. Okay? Now those are two different things. You can't just say, oh, those are the same thing, congruent, same thing, equal. No. This, again, is referring to the measure. So how long is the line? The actual number itself. This one is referring to the line segment. It doesn't care about the number. It's only comparing the two shapes. So the different symbols compare two different things. They relate to each other, but they compare to two different things. Next, I want to talk about a congruency symbol. Whenever you want to say that two things are congruent, you're going to mark it with a little tick mark like that. The more individual pieces you have, the more tick marks you're going to use. So for example, let's say I have this rectangle. Okay, so A, B, C, D. And I want to say that the top and the bottom are congruent, and then the two sides are congruent. Okay, well, AB is congruent to DC. I'm going to put one tick mark on those. Next, if I wanted to say that AD is congruent to BC, I've already got one tick mark, so now I'm going to do two tick marks. Okay? And if I had a triangle, I would use a third tick mark if I needed a third. The different tick marks show you that those two, or those segments, are congruent to each other. So pay attention to your tick marks. That will show you what's congruent to what. Now, this last one, bisector of a segment. A bisector can be anything. It can be a line, a segment, a ray, a plane, anything that intersects the segment at the midpoint. So if here's my segment right here, we use the line from above. So A, B, with P in the middle. And then to prove that it's my midpoint, I'm going to annotate it properly with my tick marks. A bisector would be something that intersects it down the middle. Okay, it intersects that point. So it could be a ray. It could be a ray that intersects it. I could continue that on, and now it's a line. I could say that I have this line right here, or this ray that intersects it. Okay? Anything that intersects the midpoint is a bisector. Now on to the stars of the show. Distance and midpoint formulas. Now distance and midpoint formulas are helpful when we're dealing with points from the coordinate plane. If you forgot what that was, the coordinate plane is the XY axis coordinate plane. Okay? Now if we were to have a vertical or a horizontal line, those are easy just to count how long it is or to measure how long it is. But 9 times out of 10, or at least most of the time, we don't get lines that are vertical or horizontal. you get some variation of a diagonal line, in which case you can't count those. That's where distance formula comes in. Distance formula takes 2 points and it tells you how far those 2 points are. So what points you're going to be using are actually the 2 end points. Let me erase my little arrows. They're going to be the 2 end points of your line segment over here. And it has to be a line segment because lines themselves go off forever in all directions. Now, this first point right here is going to be x1, y1. Second point is x2, y2. Now, it doesn't really matter which one's x1 and x2, which one's y1, y2, as long as they go together. x1 has to be with y1, x2 has to be with y2. And what that little bitty 1 and 2 tells you is that there's 2 x coordinates. This one's the first one, this is the second one. It's math, guys. We love labels. We got to make sure we know what we're talking about. So, make sure you have the distance formula copied. This is what we're going to be using, and you can see where you plug things in. Now, midpoint formula, you can probably figure out what it does. If distance formula tells you how far those 2 points are, midpoint formula tells you where on the line the midpoint is. Ta-da! We can also use it to find one of the endpoints if we're given the midpoint. So that's 2 variations of the ways you can use this formula. One is to find the midpoint, and the second way is to find an endpoint given the midpoint and one endpoint. Okay, so we can use midpoint formula in a few different ways. Let's start practicing. Distance formula. So first off, please make sure you have this written down if you didn't write it down already. Distance formula is x1 minus x2 squared plus y1 minus y2 squared. Now when I'm doing my problems, I like to label my points. There's a lot of moving pieces. Labeling points takes down the amount of error, or takes down the room for error. So there I have my points labeled. All I'm going to do is plug them directly into the equation. So what I'm going to get is d is equal to the square root of 7 minus 3 squared plus 2 minus 4 squared. And then you just simplify. 7 minus 3 is 4 squared plus negative 2 squared. 4 squared is 16 plus 4. Don't forget about your signs. Remember, a negative number squared is a positive number because a negative 2 times negative 2 is a positive, which means we have the square root of 20 as our distance. Now, just like with fractions, once you get your square roots, you have to break them down and simplify your square roots. Okay, and by simplifying our square roots, we're looking for the perfect squares. So I'm going to take 20 off to the side, and I'm going to break this down using a factor tree. Okay, I'm looking for perfect squares. So my first thought is there a perfect square that goes into 20? I answer myself that yes, there is. 5 and 4. 4 is a perfect square. Okay, the square root of 4 is 2. Okay, it breaks down into 2 and 2. Which means that as I rewrite my answers, one of these 2's is going to come out of the radical and the other one goes away because the square root of 4 is 2. Okay, so that means the 2 is going to come out. This 5 is not a perfect square, nor does it have a buddy, so it's going to stay inside, making my final answer 2 root 5. Now, if you are shaky in any way on simplifying radicals, please let me know, and we'll go over it in class. For now, go ahead, try the next one. The video is going to pause. When it plays again, you'll see the answer. And there you go. Now in this problem, I made sure to show all the different in-between steps because this one is unique with the signs. Pay attention, pay very close attention to the signs. All right, with our x's, we have -5 minus a -4. Don't forget that when you're subtracting a negative, it becomes a positive. And then again, on this next step right here, stop that. On this next step right here, and then even over here, whenever you square a negative, the answer is a positive, which is how we get +9 and +1. Now, when we take the square root of 10 off to the side to see if it breaks down into a factor tree, our only two factors are 5 and 2. Neither of these are perfect squares, so it cannot be simplified any further. And our answer is going to stay, the distance is the square root of 10. Always double check your radicals and make sure they cannot be simplified further. There will be some you can recognize automatically, but if you're not sure, always just take it off the side and break it down. Now let's go to our midpoint theorem. The special thing about the midpoint theorem is that it is actually two equations. And as I'm writing them, you can see the two individual equations. You have the equation that helps you find the x-coordinate, right here, and then you have the equation that helps you find the y-coordinate, right there. Remember, most of these problems are going to be on the xy coordinate plane, so it's going to be on a graph, which means your midpoint is going to be a xy coordinate point. The reason why this is important is because that means you're looking for two things. You're looking for the x and you're looking for the y's. All right, let's do a few examples and play this out. So this first one, find the coordinates of m, the midpoint, get of st for s, -6, 3, and t, 1, 0. All right, again, I am going to label my points. It just makes life easier, and it decreases the odds of mistakes. So I'm going to make this x1, this y1, x2, y2. Once I have that, plug it into my equation. So the midpoint, I'm going to do the x's first. So I have 1 plus -6 divided by 2. 1 plus -6 is really just 1 minus 6 divided by 2. This is going to be a -5 over 2. Do not be scared of fractions. Fractions are numbers too. Be nice to them. Next, I'm going to solve for my y's. This one I have 0 plus 3 divided by 2, which gives us the lovely answer of 3 over 2. Again, be nice to fractions, which means that our midpoint is -5 over 2, 3 over 2. And that's your answer. And you're going to leave your answer as this. Do not turn it into a mixed fraction. Just leave it as an improper fraction. Leave it alone. All right, go ahead and try 4a on your own. The video is going to pause. When it plays again, you'll see the answer. And there's our answer. I'm going to point out a few things to you as you check your work. Number 1, a little bit of notation over here. You see me writing x sub m and y sub m. This isn't necessary, but I like to have these every so often just to keep our work organized. This means that I'm looking for the x, the midpoint's x. This means I'm looking for the y of the midpoint. Okay? It's just a little trick to help keep your work organized and to help you find your pieces faster. And then over here, your answer must be a coordinate point. If you are given 2 coordinate points, your answer is going to be a coordinate point. This means that it has to be in parentheses separated by a comma, just like this. Coordinate point is a parentheses x, comma, y, close parentheses. We need to make sure we're doing proper notation on all of our answers. Now, this is one type of problem, okay? You are given the midpoint, or you're given the two endpoints, find the midpoint. The other kind of problem is down here. Now, in this kind of problem, you're given one of the endpoints and a midpoint, and you got to find the other endpoint. So let's read these. Find the coordinate of j if k is -1, 2 is the midpoint of JL, and L's coordinates are 3, -5. So we are a visual culture. If ever you get confused, just go ahead and draw it. Okay, we have JL, and I'm sure this is not exactly what it looks like on the graph, but for the sake of our picture, we're going to go with it. And that means K is in the middle. Now we are given K of -1, 2, and we are given L, which is 3, -5. This is most definitely not how it looks on the coordinate plane. But the reason why I drew it like this is so that you can see what we're looking for. Okay, we are looking for J over here, which means we can't use the equation the same way we did in the last problem. We got to tweak it a little bit. Not much, but just a little bit. Now, let's go with the x's first. Our equation for the x's was x1 plus x2, it's not a 2, divided by 2. Now I'm going to add my little notation over there, is equal to x sub m, the x of the midpoint. Let's look at what we have. Here, my endpoint, this is going to be x1 and y1. J is my other midpoint, so that's where x2, y2 is going to be. So I'm going to erase this. And do a x2, y2 over here. And then in the middle, I have my x sub m and my y sub m. Okay, again, those are just notations to indicate this is the x of the midpoint and the y of the midpoint. Now that I have everything labeled, I'm going to take all of that and plug it into the equation. So, my x1 is going to be a 3. My x2, I don't know, so I'm just going to leave it as an x. Divided by 2, my x of the midpoint is a -1. Here I have an equation, and now I'm just going to solve for x. So in order to get the 2 out of the denominator, I'm going to multiply both sides by 2. This will cancel on this side, and now I have 3 plus x is equal to a -2. Running out of room here. I'm going to subtract 3 from both sides, which means I now have x is equal to a -5. And that is the x of the j point. Now I'm going to do the same thing for the y's. Let's see if I can get a little more room here. Change color so you can see what I'm doing. Okay, so my y1 was a -5. Plus, I don't know what y2 is, I'm just going to leave it as y, divided by 2 is equal to the y of my midpoint, which is 2. Now I'm going to solve for y. Multiply both sides by 2. -5 plus y is equal to 4. Plus 5 to both sides. And that means that y is equal to 9. This means our final answer, the point of j, is going to be -5, 9. Now, if you wanted to help you get a better idea of what the picture looks like, you could have sketched this on a coordinate plane. It wouldn't have taken much. So L is 3, -5, so that's 1, 2, 3, -5, 1, 2, 3, 4, 5. So here is point L. K is -1, 2. All right, there's K. and then J would have been somewhere over here-ish. So as our line goes, it would have gone in this direction, and we wouldn't have known quite where J was to finish it off. But now we do. Now we know that it's -5. I'm a little off scale here. But now we know that this is -5, 9. Okay? So this is how it would look on a coordinate plane drawn correctly. The only reason why I drew it that first way is so that you could see what point we were looking for. And make sure that you're always being very, very careful when you read the questions and that you know which coordinate point you're looking for. You guys go ahead and solve this one of 5A over here. The video is going to pause. When it plays again, you'll see the answer. And there you have it. On this one, you were looking for G, given that P was the midpoint of segment EG. If you have any questions on any of this, please make sure to ask in class. Now, distance and midpoint formula don't have to have coordinate plane points. That's just where the bulk of the problems are. There are many cases, like with midpoint formula, where you just have a regular segment and you need to find the midpoint of that segment. Now at this, you're going to rely on segment addition postulate. And I'm going to abbreviate because abbreviate. You're going to rely on segment addition postulate for your starting point, which is a reminder that when you add the two pieces together, you get the whole. So segment AB plus BC is equal to segment AC. And that's the equation taken from the definition that you should already have in your notes. Here we go. If M is the midpoint of XY, MX is 12A minus 20, and MY is equal to 5A plus 11. Find A. Whenever you have these pictures, or whenever you have these, go ahead and draw your picture. It is so much easier to just draw the thing out. It doesn't take that long. So MX is 12A minus 20, and then MY is 5A plus 11. Now, according to the segment addition postulate, piece plus the piece equals the whole. Well, the immediate problem that I see is that we don't know what the whole is. Okay? However, we know the definition of the word midpoint. Midpoint says that this is a point in the exact middle. Okay? It cuts the segments in half. So that means that line segment XM is congruent to line segment MY, which means that line segment XM is equal to line segment MY. Okay? And because they are equal to each other, I can say that 12A minus 20 is equal to 5A plus 11. Now this is an equation I can solve quite easily, and I can find what A is. Okay, this is going to be 7A plus 20 is equal to 31, which means that our answer, A, is equal to 31 over 7. Don't be scared of fractions. They're numbers too. Be nice to them. All right, now the next one, again, we're going to draw our picture first and then look at what we need. So M is the midpoint of XY again. So here I go. I'm going to draw the picture. Here's X. Here's Y. And then M is in the middle because it's the midpoint. I'm going to do my congruency marks so that I know it's the midpoint. Okay, so XY, here we go. XY is 10B minus 24. MX is 2B plus 6. We need to find MY. Okay, now again, segment addition postulate states that piece plus piece equals the whole. Okay, this one's nice. It gave us the whole, but now I don't have both pieces. Again, go back to the definition of midpoint. Midpoint means that these two pieces, these two segments, are equal, which means that xm is still equal to segment my. So now there's two ways you can start this equation. I can either say this piece is 2b plus 6. So I can either say I have 2b plus 6 plus 2b plus 6 is equal to 10b minus 24. It's a bit to write. Or you could say that 2 times 2b plus 6 is equal to 10b minus 24. Okay? Either way are valid. Both say that you have the two pieces and they are equal to the whole. It just depends on which way you see first and makes the most sense to you. Pick your favorite, move on with your life. Go ahead and solve. When the video plays again, you'll see the answer. Final answer is 6 is equal to b, or b is equal to 6. Okay guys, this marks the end of the video. If you have any questions, please make sure to ask me in class, and I'll see you next time.